Hello dear students. So I again welcome you all in this class. This is lecture number 3rd of this amazing topic, carbon and its compound. So let's begin this session without wasting our time. Okay students, so here we will talk about the covalent bond in oxygen. In the previous lecture we saw the covalent bond in hydrogen. Okay, now we will see the same thing for oxygen as well. So let's talk about this. In the case of oxygen, we see the formation of double bond between two oxygen atoms. This is because an atom of oxygen has 6 electrons in its L shell and it requires 2 more electrons to complete its octet. So basically guys, here we all know that oxygen has atomic number 8. Atomic number of oxygen is 8. So if I write the electronic configuration for oxygen, then it will be 2 and 6. Now in the L shell you can see there are 6 electrons. Okay, now guys, what will happen if this oxygen atom wants to complete its octet? Then it requires two more electrons. Okay, so to complete its octet, what will this oxygen atom do? It will share its 2 electron with another atom of oxygen. You can see here in this picture, this oxygen has 6 electrons in its valence shell. 1 2 3 4 5 6. Now this another atom of oxygen also wants 2 electrons to complete its octet, and it has also 6 electrons in its valence shell. 1 2 3 4 5 and then 6. So what will they both do? They will share their electrons and it will complete their octets. Now you can see after sharing 2 electrons, you can see both the octets or octets of both the elements is completed. 1 2 3 4 5 6 7 and 8 for this oxygen, and for this oxygen also you can see that there are 8 electrons in the octet of this oxygen. 1 2 3 4 5 6 7 and 8. So guys, thus octet of both the oxygen is completed and they made covalent bond. Okay, so I hope guys the covalent bond in oxygen is clear to you. Now one more thing you have to remember, that because there is a sharing of two pair of electron, okay, 4 electrons are shared, it means 2 pair of electron is shared. So that's why this is said to constitute a double bond between two atoms. This is what? Double bond. Double bond. And this double bond will be shown by 2 single lines like this. Okay, so if you see these 2 single lines between 2 atoms, so you will automatically understand that there are sharing of 2 pairs of electrons. I hope guys this point is clear to you. If there is only sharing of 1 pair of electron, then I will denote it with single line like this, single line. This is what? This is used for single bond. Single bond. So I hope guys this point is clear to you. The 2 electrons contributed by each oxygen atom, it will give rise to 2 shared pair of electrons, and this is said to constitute a double bond between the two atoms. So now, after understanding this covalent bond in oxygen, let's move ahead on the next slide and let's see some example so that this concept will get more clear and you will have more clarity that how do we make electron dot structure if this is asked in question. So let's move on to the next slide. Okay students, so here we are. Here we will talk about an example so that we will understand what we have seen in the previous slide. So in this question, it is said that can you now depict a molecule of water showing the nature of bonding between one oxygen atom and two hydrogen atom. So basically in this question they want us to draw the electron dot structure of water molecule. Okay, so we all know that what is the chemical formula for water. This is H2O. Now if I draw the electron dot structure of this water, then you can see that two hydrogen atoms are connected with one oxygen atom. So how is this possible? Let's suppose I have a oxygen atom. Now we all know that in the valence shell of oxygen there are 6 electrons present. So I will draw those 6 electrons like this: 1 2 3 4 5 and then 6. Okay, now guys, we also know that in the valence shell of hydrogen or in the K shell of hydrogen there is 1 electron available. Now you can see that in H2O there are 2 hydrogen atoms. So this is another hydrogen atom and it has also 1 electron in its K shell. Now guys, what will happen if this oxygen wants to complete its octet? So it needs 8 electrons, and if this hydrogen wants to complete its octet, then it also needs 1 electron, or you can say 1 more electron. Okay, because it wants to complete its octet, and if hydrogen wants to complete its octet, so it needs to attain the electronic configuration of the nearest noble gas of hydrogen, and that is helium. Okay, and helium has 2 electrons in its K shell, so it also wants 2 electrons in its K shell. So guys, what will happen? This hydrogen will share it 1 electron with this oxygen. Okay, and this oxygen also share its electron with this hydrogen. Now this hydrogen also needs 1 electron to attain the electronic configuration of helium, so it will give this 1 electron, or it will share its 1 electron with this oxygen like this. Let me draw it clearly like this. And now guys, you can see that the octets of these 3 atoms or the elements are completed. How? Let me show you. This oxygen needs 8 electrons. So you can see now after sharing 1 electron with this hydrogen atom and another 1 electron with this hydrogen atom, it completes 8 octet. You can see 1 2 3 4 5 6 7 8. 8 electrons are there in the L shell of oxygen. So this means you can say that oxygen has completed its octet. And this hydrogen also, you can see that after sharing 1 electron with oxygen, there are 2 electrons in the K shell of hydrogen. So it also attains the electronic configuration of helium. And this hydrogen also has 2 electrons in its valence shell after sharing 1 electron with oxygen. So these 3 elements have completed their octets. So I hope guys this point is clear to you. Now let's talk about the another question in this slide, that does the molecule have single bonds or double bonds? So we all know what is the difference between single and double bond. In double bond there is a sharing of 2 pair of electrons, okay, and in single bond there is a sharing of 1 pair electron only, okay. Now here you can see that there is a sharing of 1 pair electron, okay. This hydrogen and this oxygen share 1 pair of electron, and this hydrogen and this oxygen also share 1 pair of electron. So I can draw this like this, okay. Single bonds are shown by this single line. So you can see there is 2 single bonds. So does this molecule have single or double bond? So of course this molecule have only single bond only, okay. You can see that there is no double bond because only 1 pair of electron is shared. So I hope guys by this example the concept will get more clear that what is covalent bond. Now guys let's move on to the next slide and let's talk about the other covalent bond or the bonding in other elements as well. Okay students, so here we will talk about the covalent bond in nitrogen. Okay, so basically guys, nitrogen has the atomic number 7. So if it has atomic number 7, so the electronic configuration of nitrogen will be 2 and 5. It means in its outermost shell or in its valence shell there is 5 electrons. 5 electrons are present in the outermost or valence shell. So it also wants to attain the electronic configuration of the nearest gas, okay, or it also wants to complete its octet. So to complete its octet it needs 3 more electrons, because after accepting 3 more electrons this will become 2 and 8 and its octet will be completed. So guys, what this nitrogen will do, if it shares its 3 electron with another atom of nitrogen or with another nitrogen element, then the octet of both the elements will be completed, okay. So how does it get done? Let's see here. You can see this is nitrogen and it has 5 electrons, 1 2 3 4 and 5, and this is another nitrogen atom and it also has 5 electrons, 1 2 3 4 and 5, okay. Now guys what will happen, you can see that 3 electrons of nitrogen is shared with this other nitrogen element, or you can also see that both nitrogen share 3 pair of electrons between them. So now if I count the electrons 1 2 3 4 5 6 7 8, so the octet of this nitrogen is completed because now the number of electron in the valence shell became 8 and the octet of this nitrogen is completed. Now guys, this nitrogen also completed its octet because it also shared its 3 electron with this nitrogen, and if you count the number of electron then it will 8. So it also completed its octet. I hope guys this point is clear to you. Now the thing which is to be remembered or which is to be noticed is that you can see there is a sharing of 3 pair of electrons or 3 shared pair of electrons. So that's why it will said to constitute a triple bond between these two atoms. Okay, so this is what triple bond, and this triple bond will be denoted by these 3 lines. Single bond is denoted by a single line, double bond is denoted by this double line, and triple bond is denoted by the 3 lines. Okay, now guys, in single bond only 1 pair of electron is shared, in double bond 2 pair of electron is shared, and in triple bond 3 pair of electron is shared. So I hope guys this point is clear to you. Now if it is clear to you, so let's move ahead on the next slide and let's talk about some examples to understand this point. Okay students, so here we will talk about this example. So a molecule of ammonia has the formula NH3. So we have already been given the formula. Can you draw the electron dot structure for this molecule showing how all 4 atoms achieve noble gas configuration? Okay, so there are 4 atoms, N nitrogen atom and 3 hydrogen atom. Okay, now guys, we became expert of drawing the electron dot structure because we have seen many examples on this. So we can definitely draw this structure. We are capable enough. Now, first of all, we need to know the atomic number of nitrogen. So here on this slide, I told you that atomic number of hydrogen is 7. So the electronic configuration of nitrogen will become 2 and 5. So this nitrogen needs 3 electrons to complete its octet or to achieve the noble gas configuration. Now guys, what will happen? This nitrogen will share its 3 electrons with 3 hydrogen atom. Okay, if it shows or if it shares 3 electrons with nitrogen atom, then the octet of the nitrogen will get completed. So we can simply, first of all, we will simply draw that this nitrogen is connected with this hydrogen, and with this hydrogen, and it becomes NH3, where these 3 hydrogen is connected with this nitrogen by the single bond. A single bond means there is a sharing of 1 pair of electron. Now guys, if I draw the electron dot structure of this NH3, then it will be easier to me that this is nitrogen. Let me change the pen. If this is nitrogen, then it has 5 electrons. Let me erase this. Okay, like this. Okay, you can see 1 2 3 4 5 electrons. Now this hydrogen atom will come from here, and it also has 1 electron, and it also wants to attain the noble gas configuration, so it needs 1 more electron. Now this is another hydrogen atom, and it also has 1 electron, and to attain the noble gas configuration it also needs 1 more electron. Now there is another hydrogen, and it also has 1 electron. Now guys, what will happen? You can see that the nitrogen will share 3 electrons with these 3 hydrogen atoms, and you can see that 4 atoms have completed their octets. Okay, this nitrogen has now 8 electrons in its valence shell. You can count 1, 2, 3, 4, 5, 6, 7, and 8. And this hydrogen also has 2 electrons, 1 and 2. This hydrogen also has 2 electrons, 1 and 2. And this hydrogen also has 2 electrons. So thus guys, you can say that all the atoms have completed their octets, or they achieve the noble gas configuration. So this is the formation of NH3 molecule. So I hope guys this formula and this electron dot structure is clear to you, and this NH3 is known as ammonia. This is very important chemical. You have to remember it. This will come many times in the upcoming slides. Okay. Now guys, if it is clear to you, so let's move on to the next slide and let's talk about the remaining things. Okay students, so now we will see this methane. This is very important. This is a simplest compound formed by carbon. Okay, 1 carbon and 4 hydrogen atoms are present in methane, and the formula for methane is CH4. Now, why it is important? Because guys, this methane is widely used as a fuel, and it is a major component of biogas. You might have heard the name of biogas, okay? And it is also a major component of CNG. The full form of CNG is compressed natural gas. This is very important. I am highlighting this. CNG, the full form is compressed natural gas, and this methane is a component, or you can say it is a major component of these two gases, biogas and compressed natural gas. So that is the reason that it becomes very important to understand this CH4. Now guys, you can see that it is also one of the simplest compound formed by carbon, and methane as a formula of CH4, I told you this already. And carbon is tetravalent because it has 4 valence electron. So in order to achieve the noble gas configuration, carbon shares these electrons with 4 atoms of hydrogen. So guys, this is basically the electron dot structure of CH4. Okay, here carbon is sharing their 1 electron with 4 hydrogen atoms like this. Here you can see 1, 2, 3, 4. These are the electron present in the valence shell of carbon, because carbon is tetravalent. Carbon is tetravalent. We have been understanding this point since a long time. So I hope this is clear to you. Now this hydrogen has 1 electron. It also wants to complete its octet. So it will share this 1 electron with this carbon, and all the hydrogen atom will share their 1 electron with carbon. And now if you count the valence electron in carbon, then it will become 8. 1, 2, 3, 4, 5, 6, 7 and 8. So it become 8. And if you count the valence electron in hydrogen, then it will again become 2. 1, 2, here also 1, 2, here also 1, 2, here also 1 and 2. So these atoms have completed their octets. Okay, hydrogen attained the noble gas configuration, and the nearest noble gas of hydrogen is helium, and carbon also attained its octet complete, or it's completed its octet. So I hope guys this is clear to you. Now let's move on to the next slide and let's talk about some important points about covalent bond molecules. So basically guys, this covalent bond is not that much strong as ionic bond. Okay, ionic bonds. So in ionic compound, you might have seen that the intramolecular force is very strong. So if intramolecular force is strong, so the melting and boiling point will also be very strong or very high, because to break the compound it needs lots of energy. But in covalently bound molecules, the intramolecular forces are weak. So if intramolecular force is weak, so the melting and boiling point will also be very low. Okay, so this give rise to the low melting and boiling point of these compounds. And what is responsible for low melting and boiling point? So weak intramolecular force is responsible for low melting and boiling point. Now guys, since the electrons are shared between atoms and no charged particles are formed, such covalent compounds are generally poor conductor of electricity. So basically guys, I told you many times that for conducting electricity, what is responsible? Free electrons or free charges or free ions. Okay, if these are not free, so the electricity cannot be conducted. Now in covalently bound compound, there is no free electrons or no charged particles, so that's why these are the poor conductor of electricity. Okay, I hope guys this point is clear to you. But here one more thing you have to remember, that graphite is a conductor of electricity. Conductor of electricity. And why it is conductor of electricity? Because there is one free electron, and because of the one free electron it is good conductor of electricity. So I hope guys this point is clear to you. Now let's move on to the next slide. Okay student, so here we will talk about one of the example. So what would be the electron dot structure of carbon dioxide which has the formula CO2? So guys, we all know that carbon is tetravalent. Okay, so it has 4 electrons in its last shell like this. Now guys, this carbon will share its 2 electrons with one oxygen atom and the other 2 electron with other oxygen atom. Okay, let's suppose this is also oxygen. So 1 2 3 4 5 6, because oxygen has 6 electron in its valence shell. We have seen this on the very first slide. Now this oxygen also has 6 electrons like this. Now guys, if this carbon share these 2 electrons with this oxygen and these 2 electrons with this oxygen like this, so now you can see that the octet of the carbon and the oxygen is completed. You can also count the number of electrons 1 2 3 4 5 6 7 8 in oxygen. Here also 1 2 3 4 5 6 7 8 in this another oxygen atom, and you can also count the number of electrons in carbon. It also became 8. So these 3 elements have completed their octets by sharing of electrons. Now guys, one thing you have to notice, that there are sharing of 2 pair of electron. This carbon is sharing its 2 electron and this oxygen also sharing 2 electron. So because there is a sharing of 2 pair of electron, so that's mean it is a double bond. Double bond, and this double bond is shown by these 2 lines. And here also you can see that there is double bond between this carbon and this oxygen, because 2 pair of electron are shared. I hope guys this point is clear to you. So I can also draw this structure of CO2 like this. There are two double bonds present in this structure. So I hope guys these points or these concepts which we have seen in this lecture is clear to you. So now I am ending this session and we will meet in the upcoming lecture. Till then, thank you so much guys and bye bye.